Papin. I'm sorry, got that wrong. And we're going to be talking about the tropics and teleconnections and just some research that Philippe's been able to do over the past couple of years. So we are excited to have Philippe with us tonight. And this is a live broadcast, so we'd love to see you interact with us. And you can do that one of many different ways. We are streaming right now on Facebook Live, on Periscope, and on Twitch, as well as our YouTube page. So if you want to interact with us, we just ask that you submit a question in the comment bar, and we will be monitoring those throughout the show. And if any apply to our guests, we'll ask them at the appropriate times. And if you have just a general weather question or something like that, we'll try to hit on those towards the end of the show. And if you're listening on our podcast version, towards the end of the show, we'll let our guests give out their social media information, most likely Twitter. And if you want to tweet a tweet to Philippe, you can do that. So again, we are on show number 276. We are going to be punting the news segment towards the end of the show because we're going to be talking about a really cool event that's going to be taking place here in the Carolinas tomorrow. So with that, I want to bring in our guest tonight. Philippe, welcome to the show. We're happy to have you.
Happy to be here.
And we're going to give you the standard first-time guest question. We want to know about your weather journey. How did you get to where you're at right now? What is that inspirational storm or person that got you into the weather world? And tell us a little bit about where you've been since then.
Well, so I started up. I grew up in Greenville, South Carolina. I was there basically my entire life through high school, and then I decided, well, early on, I was very passionate about meteorology. I actually used to be afraid of thunderstorms and lightning especially. And through that fear, I was also afraid of maybe hurricanes and other sorts of things impacting my household and whatnot. But over time, that fear turned into a passion, and I became actually very interested in following the weather. And from there, I decided I want to do this for my career. So I went to UNC Asheville to get a bachelor's degree in atmospheric science. So I completed my degree there in 2011, and then I went up to the University of Albany to get my master's and PhD, and I graduated from there in 2017. And so since then, I've moved from the East Coast to the West Coast. So I'm now in Monterey, California, working as a postdoc at the Naval Research Laboratory.
That's really cool. We didn't talk about this before the show. You're from Greenville, one of my most favorite places. It's a hidden gem in the entire United States. Downtown Greenville is beautiful. If you've never been there, you got to go. This is a little tourism speech, but
I completely agree with you. It's gotten so much better.
It really has. It's a good place. So, Shay, I know you and Philippe are really connected, so I'll let you go ahead and start the interview.
Hi, Philippe. Welcome to the show. We're glad that you could join us tonight.
Yeah,
you cover quite a range of topics. Very fascinating studies that you've done. I mean, you've done anything from tropical development to upslope snow, flooding. I mean, all kinds of really fascinating topics, and you seem to have a really good beat on things. A lot of really good graphics that you put out and explanations. You sort of bring it to lay terms for a lot of us meteorologists that aren't maybe as advanced in some of the things that you've done. But I tell you what, you've done some great work out there. And so, I kind of want to lead off with some tropics, right? So
sure.
I know one of your areas of expertise is the tropics. And so a lot of folks are asking me now, since we're nearing the June 1st, which is the beginning of the tropical Atlantic season, June 1st to November the 30th. What are we looking at here? We've seen a prediction from CSU, near average. We've heard above average, but maybe not as active. We've heard a lot of different things going on, and it's been a fairly quiet May so far. Nothing subtropical in development. The oceans are just slowly warming. Or the Gulf of Mexico and the Atlantic are slowly warming. Not much activity, but what are you seeing for right now going through the beginning of the season, and what maybe do you see for the entirety of the season?
Right. So you're correct that there's been a couple of outlooks that have come out so far from Colorado State University and also NOAA that have kind of predicted near normal activity, probably less activity than what we ended up with last year. And there are really a number of different factors that are related to those predictions. So first off, a very important impact is what's known as the El Nino effect. And so basically last year we had sort of a weak El Nino that was developing, and there's some projections that we may continue to have El Nino conditions into the second half of 2019. And so that would actually put a damper on tropical cyclone activity in the Atlantic Basin, because that would help to increase vertical wind shear in the Caribbean. and then what is typically the main development region for tropical cyclones in the Atlantic Basin. Another factor that we look at oftentimes is sea surface temperatures that are taking place, and what the current sea surface temperature anomalies are over the Atlantic Basin, how those might be evolving into the hurricane season. And so right now we're essentially right around average for this time of the year in early to mid-May. And currently that's, right in line with what your expectations would be for probably a near average hurricane season, with only just sort of a middling amount of hurricane and major hurricane activity. And I guess just to kind of, talk a little bit about the early part of the season. So far, we really haven't had much activity in the Atlantic Basin. And that's not, again, surprising, since sea surface temperatures at this point are really not supportive for development anywhere outside of maybe the Caribbean Sea. And in the Caribbean, this year has just been way too strong for any sort of tropical development.
Right. So let's talk about El Nino. Folks want to kind of understand what's the relationship between El Nino and La Nina to the Atlantic Basin and the Gulf.
Right. So El Nino basically is just talking about warming sea surface temperatures that take place in both the East and the Central Pacific. And that happens when traditionally you get really warm sea surface temperatures in the summer months in the West Pacific, but in El Nino type situations, that water tends to slosh back to the Central and East Pacific, and you can get much warmer than normal sea surface temperatures in that area. So the main effect of that over the summer months is that it produces a lot more convection and thunderstorm activity over those warm ocean waters in the East and Central Pacific. And so while that actually might help to enhance tropical cyclone development in the East and Central Pacific, that same sort of thunderstorm and convective activity can then produce strong outflow. And that outflow ends up actually enhancing the shear as you get further to the east into the Caribbean and then into the Atlantic Basin. And so it's that increased shear that kind of prevents storms that are coming off the African coast, easterly waves and other sorts of disturbances. As they're moving into that area of very high shear, it tends to blow the thunderstorms off in a tilted fashion. And in order to really get a nice, strong tropical cyclone to develop and organize, you need a vertically kind of coherent and straight up and down structure for your thunderstorms. And so any sort of kind of spread out of that energy for that thunderstorm activity tends to inhibit development. Right. So that's why El Nino tends to be negative for tropical cyclones in the Atlantic Basin.
Very good. So in the Atlantic, are we looking at any anomalies? I know we can get real techie, but we try to keep this on lay terms here for our audience. Right. Saying, what are we looking at in the Atlantic? We have, average temperatures. Do we have any cold pools, any warm pools, any equatorial processes that may spark the season off a little stronger, a little earlier, or are we just going to kind of ride through and just look at average type of season?
Right. So I think at this point, the areas that you typically look for developing activity in the early part of the season, like into May and June, would not necessarily be deep in the tropics. It'd be more sort of in the subtropical latitudes between 20 to 40 degrees north. And these would actually be areas that are just off the East Coast or in the Gulf of Mexico or kind of out near the area near Bermuda, kind of in the northwestern portion of the Atlantic Basin. And so those areas are actually well above normal in terms of sea surface temperatures for this time of the year, especially as you get farther north of Bermuda. There's kind of a warm pool relative to normal. We have much warmer sea surface temperatures. So as we get into sort of the latter half of May, and especially in June and July, if those anomalies persist and we still have much warmer than normal sea surface temperatures, then that could actually be a source for potential tropical cyclone development early on in the season. And so these would actually be storms that would be relatively close to the United States, but early on in the season, the sea surface temperatures, even if they're warmer than normal, tend to only be very marginal. And so these wouldn't really support very strong hurricanes or major hurricanes. These tend to be more sort of middling, weak to moderate tropical storms, essentially, at this time of the year. But it could potentially lead to more of those, just not the very big storms you expect later in the season in August and September.
Gotcha. And we're going to get a little bit more into that when we bring up PV streamers later, and how breaking waves across the tropical Atlantic could maybe enhance storms or maybe even help with rapid intensification. We'll get to that later. I think Melissa's going to jump in at this point. She's got a question for you going forward.
Sure.
So one of the things that Shay just kind of mentioned is we really like to demystify some of the terminology that meteorologists use when they're discussing just the regular terms that are kind of in our language, our colloquialisms. One of those is, you were talking about El Nino and you're talking about the strength of them. And I know you've done a lot of research about Rossby waves and using that to help kind of do the forecasting for what could come. So for just those people who are not sure what a Rossby wave is, can you kind of talk about them and why they are really kind of a good indicator with those teleconnections?
Sure. So, I mean, a Rossby wave is really just a fancy term for a wave at a certain location in the atmosphere. And so in the upper levels of the atmosphere, you oftentimes have ridges and troughs. And so Rossby waves are basically the flow that's occurring around these ridges and troughs. And these individual kind of couplets of ridges and troughs represent kind of one Rossby wave length. And so Rossby waves in the northern hemisphere tend to propagate from west to east. And so basically, a lot of times you'll have a trough that makes landfall on the west coast of the United States. And then over the course of the next 2 to 3 days, that same trough is then marching through the United States and then emerging off of the Atlantic Ocean coastline. And essentially, these features are running right along the jet stream, or this strong area of wind that occurs in the upper troposphere. And these Rossby waves are carried along by that strong wind in the upper portions of the atmosphere. So hopefully I don't know if that's super simple, but hoping to demystify some of the terminology here.
No, I think you did a really good job explaining that. And I think at this point, Shay's going to jump back in and we're going to talk about those PV streamers.
Sure.
Right. So PV streamers, they've kind of been a topic that have been more of a quiet topic for many years. And then we're starting to shed more light on what these areas of the atmosphere actually do according to the tropics. So maybe speak to what a PV streamer is. What are we looking at? Is it just a weakened area of the atmosphere that allows for moisture content to build, or how is it affecting the tropics?
Yes, that's a great point. So I'm going to try to share my screen here. I think I have sort of an image that might help to sort of illustrate what a PV streamer is. So let me give that a shot real quick. There we go. Share my screen. And then I will pull up this. There you go. Can you guys see that? And I'm going to make this image much bigger so it's easily visible.
Yes, we can see.
Yeah, absolutely.
Perfect. All right. So there's a lot of terms on here, but I'm going to focus sort of on the contours here and then the shading. And so the shading is what we call potential vorticity. And in simplified terms, you can think of this as vorticity, or basically turning in the atmosphere. And so oftentimes, as we were talking about before, Rossby waves are associated with ridges and troughs. And this is basically a couplet where we have a really strong ridge that has formed just off of the United States. So this is the East Coast right here. And this is an anticyclonic ridge that's associated with anticyclonic or clockwise flow that's going around here. And this is associated with very low potential vorticity air. So in some cases, these ridges grow so large that they actually start to fold in on themselves. And downstream of where this ridge forms, you actually start to see high PV air, or air greater than 2 PVU, following the scale in this particular plot, that folds underneath this anticyclonic clockwise flow. And so it's this high PV area that forms underneath that what we call a PV streamer, because it's this stretched flow of high PV air that's being basically moved underneath this clockwise spinning anticyclonic ridge. And with that, actually, high PV air is associated with cyclonic flow, or counterclockwise flow, that goes around this sort of upper level trough feature. And so it's this little feature that occurs almost repeatedly over the Atlantic Basin in the summer months. And sometimes this could then disrupt features that are forming further downstream, such as like easterly waves or disturbances that are coming off the African coast that start to approach the Lesser Antilles and the Caribbean Sea.
Understood. And is Saharan dust also tied in with that? It looks like it's awful close to where maybe some of the upper level dust is coming off at the mid levels. So how is that tying in with the PV streamers?
Right. So sometimes that can actually occur where you might get a huge ridge event that propagates all the way to sort of the coast of Africa. And then that can basically help to then push a lot of African dust off of the African coast into the Atlantic basin. And so that does happen occasionally, but a lot of that is determined by how strong the ridge is and also how far it's able to move towards sort of Europe and Africa, and whether or not it's going to then have an impact in the lower portions of the atmosphere where the dust exists. I'll stop sharing my screen here now.
No, that's really fascinating. I think we've seen it at some points where we have that kind of a setup, and sometimes you'll get something that comes off really impressive off of Africa, and it stays rather small and compact, and it's able to sort of weather these atmospheric inabilities or limitations and sort of glide underneath at the surface and then reemerge beyond that. Is that something you've seen, or is that basically that kind of combination a total debilitating factor?
Yeah, so that's a good point. And actually, let's see, I might have another good example to share here if I can bring it up real quick. Maybe not. So essentially what happens sometimes is that you get disturbances that are coming off the African coast, and they do basically have to battle this relatively unfavorable environment, whether that not be dry air from a Saharan air layer outbreak or high vertical wind shear from a PV streamer. And so in some of those cases, the PV streamer may be weak in nature, and so it's not able to generate as much very strong high wind shear that would blow the thunderstorms off of the center of the disturbance. But in other cases, the PV streamer is too strong and the system is not able to continue to develop because the shear is just too powerful to be able to allow the system to remain vertically upright. And so a lot of it is dictated on just how unfavorable the environment is. How dry is the air? How strong is the upper level winds? And whether or not that's going to reach a threshold that the storm is not able to recover from.
Yeah, it's hard to relay how difficult it is for any tropical waves coming off of Africa. They immediately have a battle ahead. They have several things that they have to get through, and right. So it's pretty fascinating to even, 1 out of 20 may make it. You can't. I mean, not an exact number, but it takes a lot to get something to form off of the African coast. The ingredients have to be just right. Plus, later in the season, we get to Cape Verde season when they form a little lower in latitude. That's a little more helpful in monsoonal troughing in the equator. So that's really fascinating.
So there, I jump in. It's like there has been some research that basically says of all these seedlings that come off the African coast, only about 8 to 10% of them actually end up developing into a system. So I think you're right on the money there with the 10% figure.
Cool. Okay, so I think Melissa, you're up. Do you have the next question?
Yeah, so we're going to kind of transition away from a lot of your tropical work because you've done an expansive amount of research and a variety of different things. But one of the things that kind of caught me is your participation in the National Weather Challenge. And you've won quite a number of awards with those. And for those people who don't know, can you kind of explain what like the National Weather Challenge is and how long you participated in it and any like advice or interesting, things that you did in that particular challenge you forecasted for or memorable events?
Sure, absolutely. So the Weather Challenge is this sort of collegiate competition that's maybe you can kind of say it's analogous to like the NCAA, but for weather. And so what happens is that it's a college competition that are based off of forecasting for a particular season for a particular city for a 2-week span. So, for example, it starts in late September, early October. You'll be forecasting for a particular city that was already set in advance, and you have to forecast the high temperature, low temperature, wind speed, and rainfall for a particular period of time. And you have to do that for every day for a 2-week period. And over the course of the 2 weeks, there are more than 1,000 plus competitors from all across the United States and even beyond that are forecasting in the Weather Challenge. And if you're lucky enough and you do well enough, you may end up with the trophy if you finish in the top 2, I think, for each particular division in the competition.
And I know that you've participated for quite a few years, and those Weather Channel challenges with them starting in September and going through October and deep into the season, you get into some winter weather forecasting, which since moving to South Carolina, I've determined is really hard to do down here in the Carolinas, is to do that particular forecasting. But is there any one particular challenge that 2-week period where it was just a bear for you to try and figure out that forecast? Is there any one of those that just kind of comes to mind?
Oh, yes, absolutely. So I still like to, even though I'm no longer a college student, I can still participate recreationally in the Weather Challenge. They actually let alumni forecast now in the competition. And this particular year, up in Alaska, I think Anchorage, Alaska ended up being a very difficult location because it was fairly close to the coast, and it was very difficult to determine whether or not you were going to get a marine impact that was going to come inland overnight, or if it was going to stay dry and radiational cooling conditions were going to take over and the temperature fell like a rock. So all the weather guidance that you used to try to make a forecast was almost useless in this case, because they were giving very similar information, but the forecast would wildly vary from one day to the next, even though the overall synoptic weather conditions weren't very different. So yeah, that strikes my mind as one of the more difficult challenges I've had with this competition.
All right. And you ready, Chris?
Yeah,
all right.
That's some really cool stuff. Going into that, we were talking before the show about some of your outreach and stuff on Twitter, especially with the weather communication stuff in the tropics. What was the motivation behind that? And for anyone that's on Twitter that's ever seen your work, I mean, you're like a rock star when hurricane season comes around.
I think you're flattering me a little too much here, but
I'm just giving the spade a spade.
Yeah. So anyway, I think I was actually pretty late to the game for joining Twitter. I didn't join until I think November, December in 2014. And so at that point, I was still a grad student at the University of Albany, and I was convinced by a few of my other colleagues that were like, "Oh, I think you would really enjoy this. You always like talking about weather with other colleagues and making different graphics for particular weather situations. So I think this would be a nice sort of niche that you would fill." And so I was like, I kind of went in with my eyes closed, not really knowing what to expect. And, Twitter can be a very interesting community. I think it's amazing kind of how the weather community has gravitated towards Twitter over the last 3 or 4 years. And it's really become a really nice community to talk ideas, whether or not that be research or forecasting or just interesting events that are occurring all around the world. And so over time, I was like, well, how can I make, an influence in Twitter? How can I sort of, potentially help to educate people? I didn't want to think of myself as someone that was very knowledgeable, but I felt like I had learned a few things through my undergrad and graduate school experiences. So I thought, well, I really like making graphics, and I like kind of animating sort of the current weather conditions and trying to explain what's going on step by step to try to help illustrate what might happen in a particular forecast situation. Or if a weather event already happened, try to recap what went down, whether or not the forecast verified this way or that way. And so from there, I've made a lot of graphics that sort of try to illustrate these types of weather events. And part of it's because I'm interested myself, and I'm not exactly sure what I'm going to see when I create these images. And so it's a learning experience for me as well when I'm creating these animations and trying to sort of diagnose what's going on. And so I do it part for myself, and then part to see if other people in the weather community agree or might be able to also add expertise as well.
Oh, that's great. And, just going into that a little bit deeper, when you say you make graphics, are you using like Python to actually create your own graphics, or are you using a third-party source?
So it really depends. So there are a lot of incredible websites now that have become available over the last 5 years for meteorologists. Tropical Tidbits, for example. One of my other colleagues, Alicia Bentley, has also put together a really nice synoptic web page for illustrating different sort of mid-latitude weather phenomena. But I like to create my own weather graphics. I use a programming language called NCL, which is it's called NetCDF command or NCAR command language, and it's actually an open source programming language that anyone could download on their computer. And I've used that almost exclusively for most of my weather career, although I'm starting to get a little bit more into Python. And when it comes to really animating this, I basically use most software that you all are familiar with, PowerPoint, to kind of illustrate and kind of like put annotations in the animation. And then I use GIMP to kind of create the animations themselves. And so it's a plethora of different tools, but most of it is open source or free to be able to use. So anyone besides myself could do essentially the same thing I'm doing.
Oh, that's great. And, thanks for the info there. And with that, I'll kick it over to Evan.
I'll take it first from Evan. Philippe, we were talking about some of your research, and we were talking about the tropics earlier. And something that we've really seen over the past couple of years is really an increase in floods and flash floods and flood events. And I know you was able to do some research off of Long Island, where a big heavy rain event happened there. So talk to us a little bit about that research, and then maybe while we are seeing more of these bigger flood events happening throughout the areas along the, well, not only along the East Coast, but everywhere. It seems like we're seeing more and more heavy rain events pop up everywhere.
Sure. Yeah, so actually the work that I did with the Long Island flooding event, this I think was back in August of 2014. And it really kind of was bred out of a class that I took at the University of Albany with one of my advisors, Lance Bossart. This event had happened basically right before the class had begun, and he was basically pitching ideas to the class on what kind of research projects would you guys be interested in. And we all decided this seems like a great project to work on. This just had happened, and it was not too far away from Albany itself, and it set the 24-hour rainfall record for this location in Long Island. And so we wanted to study it more, and we decided the best way to do that would be to sort of do a numerical weather analysis of the event. And so these types of events actually happen quite frequently, not just in Long Island, but across the United States, where you just get heavy training rainfall over a location over a period of time. What was special about the Long Island flooding event, though, is that the rainfall rate was extreme. And you can get an extreme rainfall rate that lasts for maybe like 5 to 10 minutes with a very strong thunderstorm that moves overhead. But that rainfall rate was maintained over a 2 to 3 hour time span. And so 5 or 6 inches of rainfall fell in a very short period of time because of those training, very heavy rainfall echoes that moved over Long Island.
It's somewhat reminiscent of the October 2015 flooding event here in the Carolinas. That was one of the more dynamic events I remember ever seeing.
Yeah, no, that's a great example too. That another example of kind of, you just have these very strong echoes and they don't move very much. You just have the same locations getting hit over and over again. And so it's the longevity of that rainfall rate more than just the rainfall rate itself that becomes very important for these flooding events.
Philippe, we've seen that a lot over the last year in Western North Carolina as we get these kind of southwest kind of upslope flows moving across the area that have dumped upwards of 10 to 12 inches in a day over places just kind of south of Asheville, as well as up towards Boone. So that's definitely something that we're familiar with as well. But I want to transition a little bit over to one of actually my favorite topic, Northwest flow. I had no idea we were going to get to talk about this tonight. So this has really made my day. So you went to UNC Asheville and you got to study and do research under Doug Miller about Northwest flow. Tell us a little bit about what you did during your research and what your experience was like. Sure.
Yeah. No, this is one of the more fun projects that I've had to work on. So my first year at UNC Asheville, I was a young, spry, 19-year-old freshman in college and didn't exactly know what I was going to be doing yet. I knew I wanted to do something weather related, but didn't know what. And so Doug Miller basically came to me and said, well, I'm putting this group together that is studying Northwest flow snowfall events in North Carolina and Tennessee. And what we do is we basically get in a van, we go up to this location in Boone, North Carolina in collaboration with Appalachian State. And thanks to one of the professors at Appalachian State, we stayed on his property in Boone and launch weather balloons every 3 to 6 hours when there's a significant Northwest flow snowfall event occurring. And so I said, this sounds like an amazing opportunity. And fortunately, later that year, we got a very big Northwest flow event. I think it was like February 2009. And we were up there for a 36-hour span, launching balloons every 3 to 6 hours as the Northwest flow snowfall event was occurring to kind of get aspects of where the mixed layer was, where we were getting ice nucleation, where was the best dendritic growth zone for the snowfall associated with the moisture, and just kind of important statistics that were not only relevant for research purposes, but these same soundings were broadcasted to all the local weather forecast offices, Greenville, Spartanburg, Morristown, a lot of the other offices nearby got to see the soundings that we were launching in near real time. So that way, that ended up becoming a very important forecasting tool for them as well.
Yeah, that sounding data I know is crucial to those kind of offices. And for people who don't know, so northwest flow is probably the most difficult weather phenomenon to forecast here in Western North Carolina. Can you tell us a little bit about what northwest flow is before we get too far into this conversation, just for the folks that kind of don't know, which is probably the majority of people?
Sure. So, yeah, you're absolutely correct. And this is something that outside of the area you may not be very familiar with, but oftentimes behind sort of synoptic cyclones that are moving through, you might have a coastal low that goes up the east coast. You get this large fetch of northwesterly flow that will originate actually in Canada and stretch all the way down off the eastern United States. And so with that northwest flow, you often have air mass that move over areas that have significant moisture, like the Great Lakes. And so Lake Michigan, Lake Superior, Lake Huron, a lot of those act as source regions for moisture that then this wind brings down to the mountains of North Carolina, Virginia, and Tennessee. And so what happens then is that you already have the sort of enhanced moist air in the northwest flow that starts to move over the mountains. And in order to basically cross the mountains, it needs to ride up and over the mountain. And in that case, you provide a source of mechanical lift that allows you to get condensation of that already moist air into clouds and then precipitation. And so as long as it's cold enough, that falls in the form of snow. And essentially, that's what a northwest flow event for this region is.
It's always fascinating stuff, how there's so many little details that feed into every little snow shower. Some northwest flow events can dump up to, I believe the record is 60 inches in Newfound Gap. And then some just bring a little dusting and a little bit of rime ice onto the trees. For people who kind of follow me on Twitter, like Philippe, I love making animations, but mostly GIFs of these northwest flow events. It's so much fun to watch the snow fall on the trees, and then especially in the months of like March and April, it's amazing how quickly that snow can melt and how quickly the ice can disappear. So I appreciate you discussing this topic. I think we've discussed at some point we're going to have to dedicate a full show to northwest flow because it is such an interesting topic. So you're going to have to come back to that. I'm sorry, you just don't have much of a choice.
Okay, no, I'd be happy to talk more about this. Snow is something that's near and dear to my heart as well. And I remember doing lots of northwest flow events, launching weather balloons, and just being utterly fascinated with the rich variety, because as you alluded to, some events produce an extreme amount of snowfall depending on what side of the mountain you are. And then maybe just on the adjacent slope, if you're on the downslope part of the mountain, you may get very little snowfall. And oftentimes Asheville actually ends up on that latter side where we get very little snow from these events. But say an area like Mount Mitchell or Mount LeConte, those areas oftentimes cash in and get very heavy snowfall amounts. So yeah, I'd love to talk more at some point.
Yeah, absolutely. I'll toss it off to Scotty for now before I talk about this topic too much.
Yeah, we're definitely going to get a show about that. Philippe, I have one last question for you. It's kind of a fun question.
Sure.
Obviously, you said you grew up in Greenville, South Carolina. Now you live out in California. So personally, not forecast. I mean, you can say forecasting, but personally, what's the weather been like? You know, you go from a more hot, humid environment in Greenville, South Carolina, to a more marine layer type environment there in California. So, what's the differences in the weather? Any challenges out there that you know you wasn't really accustomed to here in the Carolinas?
Right. So you'd actually be very surprised. You're absolutely right that one of the big factors that we have here on the West Coast is the marine layer, and so it's basically this very thin layer of stratus clouds that will essentially be semi-permanent just off of the west coast of Monterey. And so predicting whether or not that's actually going to come inland and cause us to have a cloudy day versus stay offshore and we end up much warmer is actually a pretty big forecasting challenge that still isn't very well understood. And so in a lot of cases, what happens is that marine layer is very sensitive to how much mixing you have in the atmosphere. So if it warms up a little bit too much and you get a lot of mechanical mixing that's taking place offshore, then that could actually cause all the clouds to dissipate and you end up with a really nice day. Other situations, it warms up inland as well, but that produces more of like a sea breeze effect where it actually helps to draw the clouds that are offshore inland. And so we end up with a cloudy day, and it's not really that much fun to be outside because the clouds bring in cooler weather as well. And so a lot of times that's determined also by not just mixing, but also by the sea surface temperatures just offshore as well. So even though the West Coast, at least particularly right on the West Coast, the variability in temperature is a lot lower in comparison to like the Eastern United States, especially Greenville, there is still a lot of interesting weather challenges that exist, especially with trying to forecast how much marine layer you're going to get. And if the marine layer does come in, whether or not that's going to be associated with drizzle or other effects that are embedded within those clouds. So, I mean, it's no matter where you live, I think there are some interesting weather problems, although it depends on what you really are fascinated by as to whether or not you can enjoy it.
That's pretty cool. I know our wind forecast team on the West Coast, they have a heck of a time getting the wind forecast in, especially San Francisco Bay Area, because you have May gray, June gloom, all the way down to San Diego. Just that marine layer built in, it could last for weeks, even up to a month at times. But they've even named some of the eddies that form off the coastline from some of that. So there's definitely a lot of challenges. You have topography, high topography, and you have those cool sea surface temperatures versus the East Coast. We have this like gradual coastal plain that kind of make things a little more predictable. But even over here, we still have our sea breeze, which is complex in itself. But yeah, that's California is a pretty tough area.
Oh, I agree completely. And some of the interesting things in the summer months is that you can have just extreme gradients in temperature as well. It can be 60 degrees where I live here in Pacific Grove, California, and just go 10 to 20 miles inland and they're over 100 degrees in the summer months. So the spatial gradient is really intense sometimes in the summer. So if you do want to get nice hot weather, you don't have to go too far, unfortunately. But, I think most people would prefer to be somewhere in the middle between too cold or too hot.
Definitely. So, Philippe, we've really enjoyed having you on tonight. If our followers who are watching tonight or those who may be listening on our podcast, how can they find you on social media?
So my weather handle on Twitter is @PP Papin. And so the first two P's are actually my first and middle initial, and then Papin is my last name. And so not too difficult to remember, hopefully.
As Chris was talking about earlier, it's a must follow on Twitter. You definitely need to go follow Philippe. Please stick around for a second if you want to. We're going to do a couple of weather roundtable events here, and we will log off tonight. I know most of us, or at least myself and Evan and Melissa and Chris, will be in Charlotte, North Carolina tomorrow, as this is a Hurricane Awareness Week, and the National Hurricane Center has their Hurricane Awareness Tour, and it'll be stopping at the Charlotte Douglas International Airport tomorrow. It is open to the public, so if you are in Charlotte or live around the area and you're a weather enthusiast and you've always wanted to check out these big planes that fly into hurricanes, you are invited out to the Charlotte Douglas Airport from 2 to 5 p.m. tomorrow. It's a free public event, so you can come in and check out the airplanes, talk with some of the flight crew. Different vendors will be there. Melissa, I know you will have a Kokoros set up there, so I'll let you kind of talk about, seeing the airplanes are going to be really cool and talking to the flight crew, but you, along with a lot of other folks, you're going to have some displays set up and some information as well.
That's right. So in total, there's over 20 different exhibitors that are going to be a part of the event. Myself from South Carolina will be representing the State Climate Office, and of course, South Carolina Kokoros. We actually have the National Coordinator for Kokoros will be there as well. We have the North Carolina Emergency Management, Red Cross is going to be there, FEMA is going to be there. We have some local fire departments that are going to be there. A lot of the local news anchors, the TV meteorologists that you love are going to be there. And it's a great way to come down, learn a little bit more about hurricane preparedness and awareness. Like Scotty said, take a look at these amazing aircraft that fly through these storms to get us the observations that they need, including one of our former guests who was back on in December, Heather Hallback, who talked about her flights through Florence and Michael, and I believe Lane as well too. So it's going to be a great event. We're really hoping to get a good turnout, and we hope to see some of you guys there. And I know that Scotty and Chris and Evan are going to be there as well. So, if you've always wanted to meet one of these guys from the Carolina Weather Group, this is going to be a real good opportunity to catch at least 3 of them If you can pry them away from the airplanes long enough to, you know, ask them a couple of questions a little bit more about themselves as well. But it really is going to be a fantastic event. The reason it's coming to Charlotte is we are going to be celebrating, if you can call it a celebration, the 30th anniversary of Hugo, which devastated portions of the South Carolina coast and even in inland North Carolina, South Carolina. It's very these tours go around, so it's been a long time since the last time that they came through the area. I believe the last time the hurricane hunters stopped through the Carolinas, they stopped in Florence a few years back. So it really is a unique opportunity to get out. I know we're going to be hosting some school groups prior to opening up for public tours. So it's going to be a really kind of neat way to engage in that STEM education portion as well, Scotty.
Yes, it is. We had Jared coming with us, but I think he's been relegated to stay in Charleston due to some work issues. So we hate that. But Evan and myself and Chris will be there. We're going to be conducting interviews and kind of just grabbing some B-roll footage, as well as having a little bit of fun talking with the hurricane experts and touring the planes and stuff. So be looking for that. We'll have some footage. I think, Chris, we're going to put a vlog together, kind of recapping our day. So you'll be seeing that later on this summer as well. So again, I wanted to read the information off to you from 2 to 5 p.m. tomorrow, Thursday, May the 9th. You can tour the U.S. Air Force WC-130 as well as the NOAA P-3 Orion aircraft and meet the pilots and the meteorologist. If you want to go, you can park in the general parking lot, Business Valet 2 parking area. So if you go to the Charlotte Airport, look for the Business Valet 2. There's going to be some kind of like tour bus there. There's shuttles at the airport. They will shuttle you to the area that you need to go. You will have to go through some security screening, but it's going to be a fun event and it's free. So we hope to see you out there. Like Melissa said, if you see myself or Melissa or Evan or Chris, we'd love to meet you and say hello. And we look forward to the event. And it's going to be a great event. And like Melissa said, I think GSP said it's been several years since it's been in our area, so they're expecting to see a big turnout. So we are looking forward to that, as well as Hurricane Awareness Week. We've been posting graphics throughout the week to help you get prepared for the upcoming season. And today is talking about your insurance. And so we just had Rob Galbraith on with us a few weeks ago, and Rob kind of gave you some tips on what you need to do before hurricane season. Remember, Melissa, is it 30 days before it goes into effect? You're on mute, but I think she said
yes, it is. It's 30 days for most policies before they go into effect. So if now would be the perfect time to reach out to your insurance agent, go over your policy if you haven't gone over it recently, whether you're a homeowner or even a renter. You know, having those insurance policies are pretty vital when natural disasters come along. And if you live outside of a floodplain, you know, talk to your insurance agent about also getting flood insurance. And that's also about a 30-day waiting period before the policy goes into effect. So if you want to get your insurance policy checkup, do it now so you have it set for when hurricane season starts, because once it starts and there is a storm threatening portions of the coast, they will actually shut down and will not sell or update any policies.
Yeah, so definitely get that checked out. You know, you've got another month or so before hurricane season starts, so you definitely want to get that checked out. Also, I'm going to kind of toss it to Chris here because I hope I'm not throwing you under the bus, Chris. But we are watching. We are watching the potential of seeing some thunderstorms this weekend. We could see some isolated, strong to maybe severe storms Saturday and Sunday. So I know you've been following that, so I'll kind of let you give an update on what we can expect weather-wise over the weekend.
Yeah, absolutely, Scotty. So we're going into this late spring pattern that we normally get to around the Carolinas here. For the rest of this week, mainly tomorrow, it's going to be highs in the upper 80s, 87, 88 degrees, depending on, you know, if you're close to the coast or up toward Greenville or in western North Carolina. But as we go to the weekend, another system is going to approach late Friday into Saturday, and rain chances to be on the increase, especially late Friday. Through most of the day on Saturday into the day on Sunday. And Sunday right now appears like the day where rain's going to be the most likely, at least across most portions of South Carolina, with rain chances better than 50%, both days on the weekend, with Sunday being maybe even greater than 60, 70%. But it's a system that's a long ways out. But anytime we start getting late spring, early summer, any kind of late afternoon thunderstorms, we got to look out for the potential, possibly some isolated severe storms, and we'll be definitely doing that. So, yeah.
Definitely. So it looks like next week we could have not really a cool down, but at least the humidity is going to drop in. We're going to see temperatures more in the average area of upper 70s. So it's been pretty warm to start off the month of May, but it looks like next week we kind of get more into an average feel and not as much humidity to work with. So anyone have anything else before we sign off for tonight? All right. Well, I'm seeing some head shakes. No, we appreciate you watching us here on the Carolina Weather Group. As always, we'd appreciate you following us on our social media accounts, on our Facebook page and our Twitter page. We'd also love for you to subscribe to our podcast, give us a review. You can find us on any of your major podcast formats and just type in Carolina Weather Group and subscribe, and you'll be able to get the latest editions. Normally they're uploaded about the day afterwards, so you can get the latest shows. And as always, we appreciate your suggestions for topics or guests. We'd love to have those. If you have any suggestions, feel free to give us a message, and we'll do our best to get that topic or that guest that you want on our show. So until next weekend, we hope you have a great weekend. We hope that you'll be out tomorrow at the Charlotte Douglas International Airport. Come say hello to us if you see us, and come tour the Hurricane Hunters. And until then, we will see you back here next Wednesday night for another episode of the Carolina Weather Group.